Hello everyone, so today's lesson is on the structure of the solar system and the universe. So first off, obviously title in your books is up there at the top, so you can write that down, pop today's date in your book, and then when you're ready, so pause the video and play when you're ready to move on. Right, so this lesson we're going to be looking at, it's going to start with our space topic, and we're going to be looking at how the universe is structured. Some of it you probably already know, both from Key Stage 3 and just from generally knowing things. And some of it will be new to you, and we're going to look at a little bit more detail about how the universe is formed. So, first off, what I want you to have a go at is to put these things into order of their size, and then can you give me a little definition of them? So in your books, I want you to put these in order from smallest at the top of your page to biggest at the bottom, and can you write down a definition for what you think these things are? Okay, so pause the video and do that now, and then play again when you're ready. Okay, so if we do that, we should have got that the Earth is the smallest thing, then the Sun, then the solar system, then the galaxy, and that last of all, the universe should be the biggest. So thinking about what these things mean then, okay, so we should have got these things for the definitions. Obviously, if yours is pretty close to this, that's absolutely fine. If not, if you need to correct something, you need to pause the video and do that. But the Earth, so Earth is the planet that we live on, so the world, okay? It's so far the only planet we know which contains life, okay? We've discovered a lot of other planets though now, and lots of them look like they could also contain life, which I'll discuss with you in a later lesson. But the Earth is our planet. The Sun is just our closest star. Now, what we just said about the Earth, it's not the only planet in the universe, okay? And the Sun is by far not the only star, and it's nothing special about it. It's a very average star. We're a very average planet around a very average star. It just happens to be the star that's closest to us, which is why it's special for us. The solar system is the Sun and everything which orbits it. So the Sun, then Mercury, Venus, Earth, all the other planets, and all the asteroids and moons which orbit either the other planets or the star. So basically, everything which the Sun's gravity has an effect on is our solar system. Now, like we said though, the Sun is not the only star in the universe, and our galaxy, or the galaxy, or a galaxy, is a collection of billions of stars. So our galaxy is the Milky Way, and a galaxy is just a collection of billions and billions of stars. And when we talk about the universe, what we mean is all of the matter that makes up space as a whole. So all of the galaxies and all of the other stuff that's in the universe all put together. Okay, so basically when we talk about the universe, we talk about everything. So the universe is everything. And that kind of is the definition for the universe, of being everything that we know about so far. So what we to have a go at next to think about the scale of these things is to try and draw Earth, Jupiter and the Sun as circles to scale. So if you just pause the video again and have a go at this, just do it in the back of your books or something. I want you to see what you think and compare it with what it actually is. So have a go. How big do you think the Earth is compared to Jupiter and the Sun? So pause it and have a go. Okay, then when you're ready, I'll go through and show you what the answer should be. So the answer should be like this. So with the Earth being this little tiny dot here, okay, that being the Earth, this big dot being Jupiter, and obviously the big yellow thing is the Sun, big orange thing anyway. So this just shows us how tiny the Earth is, and just to get an idea of this, I'll put this website link up here. I'll put it in the description as well. But this is a really nice little way of visualizing it. If you go to that, if we want to pause the video and go to that website, just have a quick look at visualizing what we mean in terms of scale, and just to see how small the Earth is compared to the Sun, and basically how insignificant we are when we compare ourselves to our nearest star. But also then like how special we are that we have life on our planet compared to all the other planets. So the Earth is tiny. It makes up a tiny, 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 tiny proportion of all of the matter in even in just our solar system. Most of what is our solar system is the Sun. Almost all of it is the Sun. Okay, and the rest of the planets make up just a really small proportion of everything else which makes up the solar system. Okay, and just to show you again, in our galaxy then, so going up in scale again, our sun is just one of these billions of stars which make up the Milky Way. We're around about here, so we're on one of the kind of outer arms. But again, just to make it really clear, we're not special. We're just a star orbiting, sorry, a planet orbiting a star among billions in the universe, in the solar system, sorry, in the galaxy, and then amongst trillions of galaxies in the universe. So what I want to do now, obviously can't do so many whiteboards, but you should be able to name all the planets, I'm sure. Okay, so you might have heard of things in school like my very easy method just speeds up naming. Okay, so you've done this in primary school or you've done this in year 7. So these represent different planets and the names of different planets. So we've got here Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. So they're the 8 planets that we have in our solar system. So we've got lots of other things in our solar system as well. We've got lots of asteroids and lots of dwarf planets and lots of comets and bigger things out in the Kuiper Belt and the Oort cloud. But if we have a look on this picture here, this shows things to scale. So roughly, what we notice about these, and you think about this, these planets that we've got in the middle here, we call these the inner planets. So let's pick a different colour. So these 4, so Earth, Mercury, Venus and Mars, we call those the inner planets. And we notice they're very close together. The distance between them is really, really small compared to, it's not small, it's really big, okay, in terms of like actually getting to things. But the actual distance between them compared to the outer planets is really small. They're also rocky, small planets. They're very tiny planets compared to the outer planets. They're very small, and yeah, they're rocky, so they're made mostly of solid materials like rocks. As we go further out then, so if we look at these planets here, okay, so these big ones over here, they are the outer planets. Sometimes called, if you call Saturn, Uranus and Neptune and Saturn and Jupiter, and we call Saturn and Jupiter the gas giants, and we sometimes call Uranus and Neptune gas giants as well, but they're more often today known as ice giants. Ooh, sorry. Ice giants, sorry, I'll just rub that out. So they are more often known these days as ice giants because we kind of discovered that they're more icy than they are rocky. So we notice a couple of things about these. First off, our outer planets are much further away from each other and from the sun than the inner planets are. The inner planets are much closer, and the outer planets are much bigger planets, and they are much further away from each other. And then we've got Pluto and the Kuiper Belt out here, and that's kind of the leftover bits, as well as the asteroid belt in the middle. And they're just the leftover little bits from the early universe. And from this, we've been able to gather some information about this and predict what the universe would be like and in the early days and how it would have formed. So what I want you to do is, first off, draw the diagram. Showing the planets. So I'll put that up at the same time for you, so you can see this and the questions. So I'd like to draw the diagram of the planets and label everything that we've got on there, including obviously all the planets. So label things like the ice giants, the gas giants, the inner planets, and then I'd like to describe the differences between them. And if you want to have a go at the extension as well, why do you think, or to think about anyway, why do you think the planets are different? Okay, so pause the video, draw the diagram in your books, label it with all the names of planets and all the different things we've got on there, and then can you describe the differences between the inner and the outer planets, so in terms of distances and composition, please. So pause it now and I'll start again in a minute. Okay then, so we're now going to have a look at how the universe formed, or how we think it formed at least, based on mostly the evidence that we've got from our own solar system. And this is kind of the accepted theory today about how the solar system formed and how the sun and the planets all formed. So we predict that the early solar system was something called a nebula. Now, a nebula is a collection of gas in space, okay? So a collection of mostly gas and rocks in space. And they're just floating around freely like this, and there would be billions of miles between the individual gas particles and individual pockets of gas and dust that make up a nebula. So there are tiny little bits of this, and if we say that each one of these blue particles is a gas, mostly hydrogen, and each one of these little particles here, if we say that is a rock or dust particle. So it's mostly gas and dust, but almost all of it is a gas. Okay, so there's loads more gas particles than anything else. So what we predict happen is that in the early universe, there were forces of attraction between the particles, and forces of attraction which we called gravity. So, for example, if we had these two particles here, this dust particle and this gas particle, there would be forces of attraction pulling these towards each other, and that would cause them to move and to come together. Okay, so that would cause the particles to come together. Now, after they've done that, that would cause then an even bigger force of attraction between the particles around it, because they join together. So then all of the particles around this would start to be pulled together because of gravity. So gravity will pull every single particle around this into the same place. So what we would end up happening is all the particles around the middle would start to pull together, and you will get especially all the gas particles starting to form into a much dense, a more and more dense thing in the middle, which we call at the minute, we call this a protostar. So this is an early star where we're getting all the gas and a few bits of the dust, solid dust in there as well. Okay, and that is going to pull in most of the gas particles, almost all of the gas particles in the solar system, okay, or in the nebula around it. So this protostar, it will eventually pull in enough hydrogen that it will get hot, and eventually the hydrogen molecules will fuse together, so you get hydrogen plus hydrogen, and they will make helium. And you might remember this from paper 1, hopefully you do, that this process here is called nuclear fusion. So this process is called nuclear fusion. So when that happens, that causes this to not become a protostar anymore, but to become a star. Okay, and that is then able to start shining, it starts giving off light. So once that has happened, so we've got our star in the middle, but we've also still got these little bits floating around. So these will start to orbit our star, because gravity will keep them in orbit around there. But if two bits are orbiting, eventually they will start to form together. Now, if you look in the middle bit, all of the gas has been pulled in. So only what is left is a few bits of dust and rocks, which will form the inner planets. And what will happen outside of that is the few bits of dust will still be there, but the bits of gas that are orbiting will start to form together into the outer planets, and they will again all form together to form our gas giants. So this is why, or this is what people predict, is why we have our inner planets much closer to our star, where all the gas has been pulled in, and our outer planets in orbits around the star much further away. Because again, if you look at the distances we've got here, okay, we've got our inner planets not that far away, quite close, whereas our outer planets are much further away. So this would be our outer gas giants. So because there was more gas in the outer solar system, further away from the star, that wasn't pulled in, that's why the gas giants are able to form further out into the solar system. So what I want you to do, if you need to watch back over this and try and do this as you're doing it, as you're watching it, right, feel free. But I want you to try and answer this question here. How did the solar system form? So I want you to say it started with a what? What do we call the thing at the start? I want you to say what force was involved in bringing the planets and the sun together? How did the Earth and form? How did this, and also how did the other planets form? So how did the gas giants like Jupiter and Saturn form? And how did the sun start to shine? You might want to do that bit up a bit earlier than that, I think, because I discussed it a bit earlier on in the kind of process of talking about this. So work your way through this. Watch back through the video if you need to. So scroll back a little bit to watch again as you go through these. But work your way through and discuss how this happened, okay? And if you can you try and explain why the inner planets are rocky and the outer planets are formed from gas? But you should be able to do the extension in the answer, I think. Okay, so pause the video, work your way through that, answers in your books as one full answer, please. Okay, when we're ready, I've got one more thing to ask you before I finish the lesson on this, which is, in fact, before I go on that, we'll go through the answers for this. So you want to be saying that the new star system is called a nebula. It is brought together by gravity, and the Earth formed because gravity pulled all the dust and rocks together to form a planet. And you could say that Jupiter and the gas giants formed because there was gas in the outer solar system, which is able to pull together to form the gas giants. And the sun started to shine because gravity pulled enough of the gas in the nebula together, and there was enough heat and pressure for fusion, nuclear fusion, to start to happen, and this then emits energy in the form of light and heat and every other type of wavelength of electromagnetic radiation into the universe. Okay, last little bit I want to show you. So this is at the moment the most accepted theory, that it should end up with the inner planets being rocky because all the gas from the inner solar system gets pulled towards the sun, and then there'd be gas left in the outer reaches of the solar system to form the gas giants. And scientists believe that this would be true for almost all stars until one day we started discovering stars around other solar systems, okay, or other stars. And the first one we discovered in 1995 was got a really inventive name, okay, as most stars have. It's just a load of numbers and letters. But it's called Pegasi 51b. And it's the first exoplanet that was discovered, so the first planet discovered around another star. And it was nicknamed kind of a hot Jupiter. So this was a gas giant which orbits very close to its star, and it doesn't fit the theory that we're used to. Okay, so it doesn't fit with what we think. So currently we think that we should have gas giants further away, and we should have small rocky planets closer to the star. But this was a big gas giant, the size of Jupiter. In fact, I think it's a little bit bigger, and it was really close to its star. So what should scientists do with this new information is what I want to ask you. And I'm not going to tell you the answer in this video. I want you to write yourself an answer down and send it to me, and we'll discuss it when you get back, what you think. Okay, so what should scientists do? We found out that what we thought was correct for all stars, we predicted this would be correct for all stars, and then we discovered a planet around another star, and this was not correct. So what should scientists do with this new information? So write yourself an answer down, and we'll go through that when you come back. Okay, that's it for today then. So hopefully you've been able to get everything you need from this. Let me know if there's any issues. Get in contact with me and I will help you with anything you're stuck with.